Good morning or good afternoon, everybody, depending on where you are. Thanks, Matthias, and all the other organizers for organizing the meeting and for inviting me to give the talk. What I would like to do today is tell you about a recently new effort of ours in building a graphical user interface that we have called Qresp to facilitate making available the data generated in scientific papers and the workflows that we have ended up using in doing the research that is presented in a scientific paper. So I think that we all agree here that we want to be able to have reproducible data and reusable data. So if this is our goal, a paper should be much more than a post-mortem PDF. So the story that you put out there in a PDF, for example, this one of a paper that we have published some time ago, is a summary of a piece of work, and often the substance of that work, meaning the data that you have generated during your research, the data associated to the figure, for example, that appear in your work, and the tools that you have used, like the codes and the experimental facility that you have used, or the script and the workflow of your work. These are usually not made available to the public. So our strategy here is to try to bring published papers to life, and not only to have a post-mortem PDF. And the idea of the strategy is to make available in a distributed manner all data and procedures presented in a scientific paper. And we have built a graphical user interface, which is explained in this paper, published 1 year ago in Scientific Data, and also at that URL, we have built a graphical user interface to facilitate organizing data, to facilitate for you to build a succinct description of the data and the workflow, and to generate searchable metadata. But before we get to an explanation of how this is done and how this looks like when you make available your data, let's step back for a minute and talk a little bit about why we want to do this. Of course, the reproducibility of experimental and computational results presented in scientific paper is a very important and critical part of the overall research process. And I think that it happened to probably everybody on this call to have tried to reproduce some data published out there, or even your own data, and not to be able to do so. And actually, this is a survey, kind of an oldish one, published about 4 years ago. It were a number of researchers were surveyed in chemistry, physics, engineering, and so on and so forth. And 70% of those who were part of the surveys basically tried and failed to reproduce another scientific experiments, including their own. And, I was not part of the survey, but certainly I'm one of the scientists who have not been able to reproduce the data of my own group, okay, and being very frustrated about that. And the funding agencies have recognized that there is a need to enforce data management, and the data management should be integral part of research planning. This is taken by the Department of Energy guidelines in the United States, and also that it's necessary to have metadata to make your data searchable, and this is taken from the NSF guideline. And the request of funding agencies came around 10 years ago, and so even today, just the presentation of a data management plan, let alone making the data available, is not exactly taken seriously by all researchers, and it's very much a work in progress. So do we really have a reproducibility crisis? This is a question that has been addressed many times in the literature, say, of the last 5 years. And I picked one paper that I really liked, and that has been published a couple of years ago. And the title says it all, really. Is science really facing a reproducibility crisis? And do we need it to? Do we really need a reproducibility crisis to do better science? The answer, in my opinion, is no. I am among the ones, by the way, that happen to believe that, especially in the field of material science, condensed matter physics, and some part of chemistry that I know, we do have a reproducibility crisis, and actually big time. However, we don't need to establish whether we have one or not, and we don't need to spend a lot of time discussing about this to do better science. In fact, we have to focus on pre-producibility. Instead of arguing about whether results hold up, let's push the community, our own students, our own postdoc, to provide enough information for others to repeat our calculation and experiments and to make data available out there. And this is a report that the National Academies, Science, Engineering, and Medicine put out there. The National Academies commissioned the report, and it became available exactly 1 year ago, where they examined the reproducibility and replicability in science. Again, without dissecting where we are and without trying to establish where we have a crisis, we can do better. We can become much more efficient and build a better path to innovation if we make our results reproducible, if we make our data available, and if we make our workflow available. And of course, reproducibility is just one of the reasons why we should care about the quality of research data. There are many other reasons. One is control. Of course, if procedures are readily accessible, this would incredibly improve the peer review process. And a very, very important one, especially right now where there have been incredible process in developing and using machine learning and AI tools, the use of digital formats that are machine readable facilitates data mining and learning activities that are now widespread in many disciplines. And so just imagine that all the data available, all the data published in the papers that you're interested in a certain field for a certain problem are available out there, are made available magically, and they are searchable because there are metadata associated to all of them. This would incredibly facilitate machine learning and AI activities, and then it will produce a much, much faster track to innovation because, of course, we can repurpose and build upon the scientific findings of others. So what are the opportunities for improvement? I actually already told you that. The opportunity for improvement is to make data and workflow available. And here we are saying, let's do this, since we are still all publishing paper, on a paper-by-paper basis, and let's bring to life our papers. The research that we do is usually pretty lossy, in the sense that the data and procedure are not made available to the community, and at some point of the process leading to a paper, of course, everything is available, but then somehow is lost. Either it's not considered very important for the text and it's put in an SI, or it's not completely verified and then it's not made available. So the information is always available at some point of the research, at least most of the information that we would find useful. We just, quote unquote, need to retain it by properly organizing, saving, and explaining it. Of course, justice, quote unquote, because it's much more easily said than done, and making available information and preparing it to be available is a very, very difficult task. And this is what we set out to facilitate, how to facilitate, how to organize the data, curate the data, and made them available. And this is just an example actually taken by one of my own papers, so that we don't blame anybody else, of a supplementary materials, which is 4 pages long. It has extra figures and tables that actually turn out to be very important. And as all supplementary materials, is not searchable. So this is an example of data that are not made available and are not usable by, certainly, like all the other data also of the paper, by other researchers. So we want to make data available. We want the data to be open, but mind you, open is not enough. First, the same way as curation of data should not be an afterthought, openness cannot be simply tackled as an afterthought. Also, as we all know, but sometimes forget, openness alone does not guarantee reproducibility and reusability. So if you just take all of your data and you don't put with them any explanation, you don't have any workflow going with them, you don't explain the software or the facility that has generated them, and you dump them somewhere, first of all, you are not making a service to anybody. Nobody will know if your data are reproducible. And if there are not metadata associated with them, then make them searchable, then nobody will be able to use it. And this is the point of this very nice perspective by Chen and others published a couple of years ago, making exactly this point that, look, open is great, but it's absolutely not enough. So let me go back to my second slide now and tell you what we did, or what we attempted to do rather. This is a very, very new product with Qresp. So Qresp is a graphical user interface which is meant to facilitate the organization of data presented in scientific paper, give a description and guide you through the generation of a workflow, and at the same time generate searchable data. And then there is a part of the graphical user interface that exposes the data that you want to make available to the public in a certain way that I will show you in a minute. So there are 3 parts to this graphical user interface: paper organization, the curation, metadata generation and collection, and exploration. So of course, so there is a URL where we have some documentation where you can download the software that we have written to have, for this graphical user interface. And we are also telling you what are the schema that we are using, and so on and so forth. So if you want to make data available, the very first thing that you have to do is to organize your paper in folder in a certain way. So one thing that we thought we would do is to present possible organization strategies for people to follow. This organization strategy, which is an incredibly simple one that I'm going to present in 2 seconds, is by no means an organization strategy that is required to use Qresp, the graphical user interface Qresp. It's just an example of what we ourselves found very useful to use to organize papers, and that we want to suggest to other people. And the way we organize paper, and also that the way they are presented in the Explorer, is to have in folder data sets, charts that are figures and tables, scripts that each researcher has generated by himself or herself during the research, tools that are either proprietary code available out there, open source code, the facilities, and docs that are additional documentation that you may want to make available with the paper. For example, tutorials on how to compute or measure a specific quantity. Once you make your data available. And again, once more, if you want to organize all of your data just as an afterthought, the barrier is much, much higher than if you actually get into the habits of organizing your data in a certain way, and so that they are more easily ready for publication once you want to tell the story. So once you have organized your data, you want to tell people the story in terms of a workflow, and you want to generate metadata, which will make your data searchable. And this is where the curator part of Qresp comes in. And the curator part is a part of the interface that facilitates for you the generation of metadata. And for example, if you go to paperstack.uchicago.edu, where we have our instance of Qresp running, and where we also have organized in a Qresp format our paper, and you click here on the curator, you will be taken to a page where the curator asks you questions that facilitate the curation of the paper. Of course, the first question is who's curating the paper, and the email address. And then there are a number of questions where you can add charts, you can add tool, you can add data sets, scripts, and of course, they must have been organized ahead of time. Otherwise, if you don't know where they are, you cannot build this curation procedure. And the very, very important thing is that every time you add a tool or a chart or a data set, you can actually create connections. So you input in this curator a data set that you have used, you input a code that you have used, and you have the option of creating connection between this data set that you have read and this code that you have used to generate another data set, and so on and so forth. And if you create this connection, then the curator will build and will generate a workflow for you that tells the story of how all the research has been done. Of course, told the way you want it to be told. While doing so, the RESTful APIs that is exposed and enabled in interaction with the database that you will use for metadata collection. The third part of the graphical user interfaces that we have built is the Explorer, where you explore the paper. So you have organized your paper, you have curated your paper, and then you make your data available. For example, server 1 here can be my server at the University of Chicago, where I have a number of papers, and server 2 can be a server in Berlin at the Fritz Albert Institute, and this server 3 can be another server of another researcher, for example, in New Zealand or at Northwestern University. And in a distributed manner, these researchers make their data available and searchable through the metadata that they have also generated and made available with the curator of Qresp. What does this mean? It means that this graphical user interface, if the researcher makes the data available, enables for federated searches across multiple Qresp portals, right? And so let's look now at how a paper looks like in the Explorer. A paper looks like a collection of figures, data set, and workflows. So let's see how this looks like, for example, for a specific paper. This is a paper where when you enter, you click on the Explorer and you look at this paper in particular, you will be able to download the data that you want. You have a Jupyter notebooks that guides you through how all the research were done. And then you have charts, and for these charts, you have the data associated to each of the charts. And not only you have the data associated to all of the charts, but as I explained a little bit at the beginning, you have a specific explanation of the data sets, the tools that you have used, the codes and the facilities, the scripts, and the scripts actually are available for download, and the workflow. And the workflow is, again, a live workflow. And if you click on all the nodes, it tells you which scripts has been used to generate which data set. And the data set can be downloaded. And if they are a very large data set, of course, you need to have access to some fast way of transferring them. And for example, Globus is one of those. Who owns the data? Actually, you choose. The researcher chooses. So first of all, of course, you choose which data to make available out there. And there can be different version of your curated paper where at different point in times you make available different parts of the data or all data at once. They can be on a self-hosted server, as I just showed you for a specific example, like over the 3 different servers. You may choose to put it on a cloud storage, or it can also be in a centralized data repository. And this is your choice. And basically, researchers store their data and procedure in the way that is most appropriate for their research. So there are many, of course, as we all know, many current efforts in material science that are based on centralized repositories. And these are, and of course, this is not an exhaustive list, but some list of also projects represented at this conference: Materials Project, NOMA, Materials Data Facility, AFlow, Materials Cloud, CTRIN, and they are all centralized repository with types of metadata and metadata that vary significantly. And one thing that we would like to do with Qresp is interface this with existing centralized repository. So you make available the data of that paper and you tell a story with your workflow. And then you also interface with the specific repository as centralized repository as appropriate for your research and as needed. We would also like to automatize data curation by optionally reading the log file produced by a workflow manager. But one thing that we think it would be nice to have is not to be locked with only one specific workflow manager, but have the flexibility of choosing the workflow manager that is most appropriate for your research. And also one thing that is still missing is the inclusion of information about libraries and environment used in calculations. And then we do need a permanent identifier without a centralized coordinating authority and for the data. And this is something that has prevented us to, for example, have the American Physical Society, with which we have been talking for a long time, to put links to the Qresp data that we have been putting out there, because they want a permanent identifier. This can be done, but we would like to be able to do this without a centralized coordinating authority, and we are trying to understand how to do this. So in conclusion, I told you a little bit about Qresp, which is an open source suite of programs that facilitates organization, annotation, curation, and exploration of data. Of course, some amount of irreproducibility is inevitable, but I think that the strategy proposed here is expected to increase the rigor in reporting results in scientific paper. And the model that we are pushing is a distributed model for search of share, which is absolutely not incompatible with the centralized data repository that are out there, with which we would like to connect in the future. I talked about reproducibility, honest reproducibility, and there is also another reason that we all know about to put the data out there and to make it available for others to see what they are, to avoid falsification and overdoing in presenting data at fakery. And this is a paper that it's quite interesting because it also gives it has appeared at the end of last year. It gives an historical perspective and also tells us about fakery of data in the old days, starting at the time of Newton, where you wouldn't expect that certain super famous scientists had been involved in some of this close to falsification of data. Anyway, you may want to have a look. So the development of Qresp is funded by MICOM, the Midwest Integrated Computational Center for Computational Material. It's and the center is funded by the OEBS. Here on the right-hand side, you see the people who were involved at the very beginning, and Tanikanti, Murakami, and so on and so forth in the first inception of Qresp. And now we have two people, one person dedicated to Qresp, Sushant Bansal, and Marco Govon is actually heading the project at Argonne National Lab at the University of Chicago. Again, thank you very much for the invitation to speak at the conference.